All right, it's time for our next talk. Cedric Dupre is with us, I hope,
Yeah,
for a talk on PostGIS, the spatial engine of IGN for 2 decades. Cedric is a geospatial data architect at IGN France, managing national scale spatial databases and infrastructure for over 20 years. IGN stands for Institut Geographique National. It's the National Mapping Agency of France. So similar in scope to the USGS in the United States or the UK Ordnance Survey. I have been looking forward to this talk for 20 years, since we first found out that EGN was using PostGIS, and at that point was the very first major international agency to do so. So thank you so much for joining us, Cedric.
thank you.
And yeah, I'll turn it over to you to take over the screen share.
Yes. Is it okay?
It is coming up. There it is. Yep, it's okay.
Good. So, hello everyone. I'm very happy to be here with you to talk about the use of PostGIS at French IGN over the past 20 years. First of all, IGN, as you said, Paul, is the French National Institute of Geographic and Forestry Information. It's a public administrative establishment under the authority of the two ministries responsible for ecology, transport, forestry, and agriculture. We have around 1,600 employees, and our missions are to collect, produce, and disseminate sovereign geographic and forest data. IGN provides open data and reference representations such as online and printed maps and advanced geovisualizations. These data cover the French national territory and forests, as well as their evolution in time in order to support public policies. We deliver fundamental datasets, including aerial and satellite imagery, high-definition LiDAR, and we are starting to produce a digital twin of France. The mapping activities focus on land use, hydrography, topography, administrative boundaries, address, agricultural parcels, and road networks. We also are the national reference for geodesy and altimetry data. And for forestry, IGN produces 3 species maps and is in charge of the National Forest Inventory. All of these resources are shared as public data and made accessible through web geoservices such as our geo platform and our mapping website called carts.gouv.fr. So who am I? I'm the IGN database expert, and I've been using and loving Postgres and PostGIS since 2007. And I've been working at IGN since 2012, but before that, I was working for the French National Forest Inventory. And if you want to know more about me, you can have a look at my interview for Postgres Person of the Week. So now, let's talk about the adoption process of Postgres and PostGIS at IGN. So we have to go back in time 20 years ago. The idea of a spatial relational database appeared at IGN in the early 2000s. Until then, relational database systems at IGN were mainly used for toponymic and geodetic documentary databases to store reference datasets. But geographical layers were produced as separated layers, and above all, they were divided into several tiles to cover the whole country. We only had a few lightweight databases produced with a GIS called GeoConcept. And as an example, we had GeoRoute, a database with a metric resolution specially developed for car navigation applications. The migration to a geographical database was carried out by 2 distinct projects: the digital dissemination of geographic data and the other project was a unified production process of vector layers that we call inside IGN BDUNI. With the digital dissemination project, our aims were to centralize in the same database geolocated data in order to facilitate their dissemination. And to offer more geoservices related to this data, we wanted to propose geometric extractions of spatial information by intersection between the different layers. And of course, these spatial queries had to run as quickly as possible at that time. And for example, waiting an hour for a query result wouldn't have been acceptable by the users. And a few years earlier, GeoServer had appeared as a good open source solution to share geospatial data. So the compatibility of the spatial RDBMS we were looking for and GeoServer was another feature we were looking for. And Oracle seemed to satisfy these requirements, but it was really expensive, and especially the spatial extension. So we had to look for other alternatives. The second project, called BDUNI, aimed at centralizing the different produced vector layers in one single database for the whole territory. And at that time, it represented more than 100 million spatial objects to store together. This information had to be updated continuously in a context of collaborative decentralized work, since we could have 2 or 3 information collectors working concurrently on the same area at the same time. This collection is made on the field, forcing us to an offline data update management. And because of this constraint, the RDBMS had to be ACID compliant and with a strong spatial extension. We did a few tests on GeoConcept and Oracle, and these first tests showed that either there would have been a lack of feature or the cost would have been really too high. So the comparison tests were done during the year 2004, and the 3 relational database management systems with spatial extension we put in competition were Oracle version 9i and 10G, IBM Informix version 9.2, and Postgres version 7.2 with PostGIS version 0.8.1. So it's very far from the version we know today. The test focused on the following points: the ease of installation and administration with a special look at backup and restore, the simplicity of maintenance, the purchase and licensing costs, the accessibility with JDBC and OODBC drivers, and the relational engine performance with non-spatial queries on an increasing number of returned rows, and in light of competing connections and transactions. And for the spatial queries performance, we tested by spatial intersections between simple and complex polygons. So as results, what emerged from the installation, use, and maintenance tests was that the simplicity of Postgres compared to the 2 other softwares. A very important point was the speed of help from the community and the efforts to find suitable answers to the problems we were facing during the tests. For the non-spatial queries performance, you can see on this graph that Postgres, which is the blue line here, improved with the increase of data volume returned by the queries and was as good as the other DBMS. On this second graph, you see exactly the same even results when concurrent connections sent concurrent queries. And once again, Postgres, as you see, was as good as the others. Comparing RDBMS and spatial queries, we noted that all of them used spatial indexation, which was a good point for having an acceptable query durations. And PostGIS was slightly slower than the others, but its execution times remained acceptable for our two use cases. So we decided to choose Postgres and PostGIS. But why? First of all, because it's free of charge. But that's neither the only nor the main argument. As I've just said, the community support in helping us resolve the difficulties we encountered was really, really predominant. And PostGIS stood up the comparison with the other spatial RDBMS in terms of performance with an easier use. We so started to implement Postgres and PostGIS on the two projects I've described before. For digital dissemination, we adopted a gradual implementation between 2005 and 2010 with the deployment of GeoServer in parallel. Since the time response of spatial intersections were very good, we quickly took the habit of using PostGIS for geometric extractions and replaced the file-based tools we'd been using for these operations before. And as I like to say, PostGIS became PostGIS for us because we use it as a geographical information system and not only to store geographical data inside the database. For the BD-Uni project, we specifically developed a geographical control versioning system that we call GCVS. And this system that still works is able to handle offline work and concurrently import the data in the database in a process we call reconciliation. If this process detects conflicts on the work area, users can resolve them manually. And as for digital dissemination project, we integrated produced data little by little to see if the database performance remained good with the load increase. I think that it was a contained risk since we always could switch to another solution if the load would have been too heavy for Postgres. But Postgres and PostGIS did it, and finally, they were adopted by the IGN. After that, let's see all the amazing other features developed by the community over the time that we have integrated to our production process. In 2010, PostGIS 2 was released with the raster layer integration. We do not store raster layers in our databases, mainly due to the volumetry and complexity of management, for example, on backup and restore size and duration. But we use the raster extension to extract data by intersecting them with vector layers stored in the database. For example, we easily get forest inventory points elevation by crossing these points with the national DEM. We also intersect these points with a lot of ecological raster layers for our production process, like radar-based remote sensing layers, probability of beach presence, and so on. And with PostGIS 2 also appeared the topology extension that we immediately adopted in production of two important national vector layers. The first one is the National Forest Species Map, and the second one is the large-scale land cover database. because both of these layers require topological consistency, it was really a good new feature that we could verify topology inside the database, and it avoided us a heavy export, correction, then import process. In 2011, Geoportail was the first French national platform developed by IGN to provide access to geographic data, perform searches, and visualize maps. It was developed by us with the help of different IT service providers. And one of the strongest requirements we had was the use of Postgres and PostGIS for storing and querying vector layers, since we knew that these technologies we used in production for a few years worked very fine. At that time, this wasn't obvious at all outside of IGN. But the providers accepted the challenge, and once again, it worked. In 2015, a little bit later, for National Forest inventory, in order to get the trees volume more precisely, we used a terrestrial lidar to collect point clouds on forest points. And PG point cloud was a perfect solution to store point cloud data transactionally and above all for long term, which was not possible with the proprietary software delivered with the scanner. The problem we encountered with this software was that the file formats became incompatible from major version to newer major versions. So storing LIDAR data in Postgres with PG point cloud became a good alternative since the volumetry was not so high. IGN also contributed at that time to PG point cloud code on the occasion of the ITONS project. ITONS is a web framework written in JavaScript and WebGL for geographical 3 dimensions data visualization. Its development was initiated by us, IGN, with the aim of visualizing 3 dimensions data containing street view image and ground lidar point clouds, as you see on the left picture. And these images were acquired by our Stereopolis mobile mapping vehicle that you see on the left picture. After that, we continued to contribute to PG point cloud. In 2017, with the major version 10 release of Postgres, we set up core functionalities inside the second version of our unified database, BDUNI, like logical replication between several database servers or JSON-B columns in the database to get more flexibility in the data model. Another important feature was native partitioning that we integrated into the National Forest map database. And the partitioning key we choose was the ground cover categories. In 2018, a little bit later in time, I discovered the OGR foreign data wrapper developed by you, Paul, which I personally used with a great satisfaction to import field collected data in the project of national forest and wildlife inventories in Côte d'Ivoire in Africa. This wrapper was very useful and facilitated data import into the database because of the different formats of files we collected, like CSV or GPS files. We also used, and we still continue to use, OGR foreign data wrapper to import S3 file geodatabases in the National Forest Inventory database. And today, PostgreSQL is the default geographic database engine of IGN. Every new project that needs a geographical database is quite systematically developed upon PostgreSQL, whether it's for data production, archiving, or dissemination. It's also used as a database for the map production line with ArcGIS server upon it. For the Geo platform I've already mentioned, it's our last collaborative and shared infrastructure for the production and dissemination of geospatial data. And as the Geo portal before, it is based on PostGIS and Postgres to store and process vector geodata. But we also use PGTileServe in a geoservice called Remonter le temps, which means go back in time. This service allows users to display aerial imagery of the same location at different dates, as you can see on this picture of Roland Garros and Parc des Princes in Paris. Picture taken in the 60s for the right side and in 2022 for the left side. And in this particular service, PGTileServe is really useful for a raster tiles pre-calculation. We have another service in Geo platform that use PG routing as one of the two methods for computing routes and isochrones when users have fine constraints. So as a conclusion, I would say that IGN made a really strategic decision 20 years ago by adopting Postgres and PostGIS for managing its data. The robustness of these tools quickly became evident for us, even though nothing was obvious at the beginning. And today, Postgres, PostGIS, and all the other tools developed around them play a real central role in the IGN production and dissemination systems. They allow us to centralize geographic and semantic data with their metadata at the same place and in a powerful transactional system. With PostGIS, we can leverage powerful spatial functions for centralized processing within the database. An important point is that all of this wouldn't have been possible without the tremendous support of the community, which is highly responsive and delivers mature and well-developed tools. I'm sure you'll agree that all of this is simply just unimaginable with commercial softwares. And to finish, during the past 20 years at IGN, Postgres and PostGIS have been regularly challenged by new solutions. But they were never replaced, and even more, they always strengthened. Thanks for your attention, and feel free to ask me any question if you have.
Thank you. Thank you so much for this, Cedric. Like I said, I've been waiting for this talk for a long, long time. We have a couple questions in the Q&A, but before we get to them, I just wanted to, you talked about the original evaluation, which with Informix and Oracle, and you mentioned the Postgres and PostGIS that you tested against those systems, and you mentioned the versions, which I did not realize, and it's incredible the extent to which the timing lined up perfectly for that. You used PostGIS 0.8.1. 0.8 was the first version that had full simple features for SQL support. So it's just like just by the nick of our knickers did we actually have a system which actually would have had enough functionality to compare with those other proprietary systems. And similarly, Postgres 7.2, which is one version later than the first introduction of toast tables, also like a required precondition to be able to do GIS in the database. So the two supporting projects just happened to reach the level of maturity you needed just at the moment you were testing them. So it was very lucky that happened. Two questions. Got a question from Doug Newcomb. Have you made an estimate of the cumulative cost savings by using PostgreSQL for the last 20 years over other proprietary alternatives?
It's very hard to say because we know that fees have increased for Oracle, for example. So it's very difficult. What is important is when you choose a new tool like that, you have to invest to have a better knowledge of the tool. But this is, and you have to invest also when new versions appear, and but this is also true for other RDBMS. So I think we really saved a lot of money. I'm unable to say a number, but how many? But it's very very important. We have uh, uh, very very much databases on Postgres and PostGIS at IGN. So I don't imagine how many we would have to pay, but it's very high, I'm sure.
Yeah,
And
well,
the spatial extension was very, I don't know if it's always the case, but at that time it was really expensive.
it was. And to give people a order of magnitude, when I was looking at it back in the early 2000s, whether we could use it, it was only available with Oracle Enterprise, and a non-seat based, like a CPU-based license was in the $250,000 range.
Yes.
It was very, very expensive. Warren Rowe asks, GCVS is an interesting topic, so I guess that's geographic and concurrent versioning, but briefly mentioned, did you use an open source tool for that? Is it available outside of EGN?
Now, it's not an open source tool because it was a specific development inside the IGN to put the data collected on the field with GeoConcept into our Postgres PostGIS database. So it's very specific to our work
Yeah,
and very specific to GeoConcept and Postgres PostGIS. So unfortunately, it's not open source, but all of the new projects we are trying to do like this one are now open source.
yeah. I have like a side question. I was always interested that the role GeoConcept played in that initial architecture. And it's like a very, very familiar architecture, like lots and lots of agencies like had desktop software sort of driving their architectures and then migrated across to a database side. And you had this sort of
Yeah.
interstitial time in between the two regimes when they have to talk together. Like, so it's been a long time. Is GeoConcept still a thing? Is it still a live product out there?
I've just learned that GeoConcept stops its GIS. So it
Okay.
still exists, but the GIS part of GeoConcept is abandoned.
Right. Also, like a note for people, like if you go back to the late 90s, early 2000s, like every country had their own GIS system. Like there's just a lot more variety in the kinds of things you would find on your desktop to do GIS. Last question is Bernie Connors. Like, was there a to total cost of ownership evaluation completed 20 years ago when you selected PostGIS?
Um, I I don't know. Um, I think, but I don't know. I wasn't at IGN at that time.
Yeah.
So probably yes, it was done, but I don't know the answer. I'm sorry.
Awesome. That's fine. It was 20 years ago. There's very few people who do now. But it's a lovely piece of history, and I thank you so much for sharing it, and thank EGN for being such a loyal member of the community over all these years. It's great to have an institutional ally out there you can point to and say, look, these people know the story, and they're not afraid. So thanks for coming and telling that story.
Thank you for your invitation.